Alright, students, in this video, I'm going to go over the attributes of absolute value functions. So this goes over several vocabulary words that you need to memorize or understand. We have the vertex, we have the axis of symmetry, we have the x-intercepts, and we also have the y-intercept. So you've seen this before when you did it in Algebra 1 with quadratics. You had, for example, let me show you, a quadratic, random one. I'll just put 2x squared minus 3x plus 1. So here's an example of a random quadratic that you saw in Algebra 1. And you back then studied the attributes of this. Where's the y-intercept at? Where's the x-intercept at? Where's that turning point, that vertex? And then the axis of symmetry for this. So what we're doing now is we're analyzing that in these type of functions, the absolute value functions. So this is the absolute value function graphed. And here's the x-axis, and here's the y-axis. And just a preview of what things are, the vertex is the point in which the graph changes direction, so it's like going down and then up. So that turning point, that's your vertex. It is a point written as a point x comma y, and it's representing the values h, k. This point is also sometimes labeled as minimum or maximum. And an example of why that's important is here, when we analyze in the calculator the graph, there's no vertex option, but there is a minimum or maximum option. So you just need to understand what it is. That way you can select accordingly what you're looking for. Or just in general, looking at it, if the graph opens up, it's a minimum. If the graph opens down, it's a maximum. So if you want to look at sketching a visual of that, that's the quadratic version of it. And then this is the absolute value version of that. All right, the next one we have the axis of symmetry. So axis of symmetry is a line that perfectly cuts the graph into two mirror images. So it's this dashed line that you see right here. And the relationship here is that if you find the vertex, you found where the axis of symmetry is, because it is the x value that the vertex has. You're just simply writing what x values. Like in this case is 3. So the equation here will be written x equals 3. So just remember the axis of symmetry is written as an equation. X equals the number. X-intercepts are the points at which the graph intersects the x-axis. So you do want to memorize which one's the x and which one's the y, because that will get you confused sometimes. And you don't want to do that. So also remember these are points, and sometimes you have 1, sometimes you have 2, based on the changes that happen to the graph. The last one will be the y-intercept, which is the point on the y-axis. Again, it's the point, so make sure you write it as a point, 0, comma y. And yeah, so those are the attributes that we need to identify. Here is the parent function. The parent function is, again, just v touching at 0, 0 on the origin. But now let's identify it with the attributes. So again, vertex, I think I have a color coordinated green, no, orange. So the vertex in this case will be the point 0, 0. So the vertex 0, 0. And then is it a maximum or minimum? Again, max is when it looks like this. Minimum is when it looks like that, because you have the lowest point. That will be the lowest point of the graph. So that's a minimum. And then we have the axis of symmetry. It's a line that goes through the vertex. So we're looking at drawing an axis right there, going through the 0 on the x-axis. So we're going to write x equals 0. It's a line touching at 0. Then we have the x-intercepts, or x-intercept in this case. It is touching the x-axis one time, so it's 0, 0. And then last but not least, the y-intercept. So y-axis, same thing, that point, 0, 0. So I'll go over 2 more examples just to reiterate what these 4 attributes are. I'm going to go over the side of the examples right here. The graph is given to you, but you can also graph it in the calculator if you like. You can just clear it and then graph it. You can leave it as f of x because f of x represents y equals. So you will just type the absolute value of x minus 3, get out of the absolute value, and then put minus 5. That graph is this graph electronically. So then if we find the vertex here, we're looking at that point. So the vertex in this case will be 3 to the right, negative 5. So 3, negative 5. And again, it's a minimum because it's opening up. And in the calculator, if you want to find that point, you will do menu, analyze, and again, there's no vertex, but it's maximum or minimum. So this is a minimum. And all you have to do is move this, you will like move with your finger right here, the screen, until this creates like a wall on the left side and right side of that turning point. So don't click on that, click on the right side, drag it over, and then it'll identify it immediately as the minimum, 3, negative 5. Then we have the x-intercepts, or axis of symmetry first, I guess, since we're already there. The axis of symmetry goes through the vertex, vertical line, right here. And the vertex starts with the x value of 3, because that's telling you what the axis of symmetry will be. X equals 3. It's a vertical line touching when x equals 3. All right, then you have the x-intercepts. In this case, we do have 2 of them. So we are going to write them as points. We have negative 2, 0, and 8, 0. And the last is the y-intercept. So for that one, it will be 0, negative 2. And just a reminder, these attributes could be found in the calculator. The axis of symmetry would be menu, analyze, analyze conics, axis of symmetry. And I believe it should have shown it, but I'll show it in class. I can't recall how to get it activated. But then as far as the other part, we have a 0 where it calculates that point right there. You can click it and drag it over like you did earlier with the maximum or minimum. But you can also do trace and then trace that point there and there until it says 0. So let me show you. It says 0, so 8, 0. And then if you go to the left, it says 0 right there. And negative 2, 0 is your other x-intercept. So the x-intercepts are found if you're looking for the word 0. And then the y-intercept does appear as well right there when you're tracing. So I'll just review how to get that axis of symmetry. But again, it's just where the vertex is at. All right, one more problem together. I'm not going to use the calculator anymore since we already have it graphed here. The vertex in this case will be right here. So we're going to write the point, which is 1, 2. This one is opening down, so that is considered a maximum. The x-intercepts here would be negative 3 and 5, but as points. So negative 3, 0 and 5, 0. Then we have the axis of symmetry, which is located where that vertex is at 1. So we're going to write x equals 1. And then the y-intercept will be right here. And it looks like a decimal. So it looks like 1.5. But since I have the tools to check, I'm going to type it in the calculator real quick. Let me see. We're going to type negative, control divide, 1/2, absolute value, x minus 1 plus 2. And then I'm going to trace. And I'll trace the y-intercept. So yeah, it says 0, 1.5 as the y-intercept. So it did look like that. I just wanted to verify since I do have the calculator. All right, so that is how you find the attributes of a absolute value function.